Hi viewers, this is Sri Ramulu. So today's topic is diffusion of gases. Okay friends, in diffusion of gases, mass will transport. So that is why transport of mass is written side. And next, let me start. Diffusion may be described as the transport of mass resulting from random molecular motion, and it takes place whenever there is a different molecular concentration in different parts of the gas. See here, diffusion may be described as transportation of mass. So here diffusion is because of mass is say. Okay, when mass moves, then gas is diffusing, right, resulting from random molecular motion. So that is because of random molecular motion. Random means the molecules may move in different direction. That is a random molecular motion, and it takes place whenever there is a different molecular concentration. Okay friends. Okay, so whenever, okay, take place takes place whenever there is a different molecular concentration. What is a concentration? Concentration means it is a number of molecule present in a unit volume. Suppose a large number of molecules are present in unit volume, then we can say that it is highly concentrated. If a small amount of molecules are present per a unit volume, then it is considered as low concentration. So concentration means number of molecule has to present per unit volume. Okay, in such case a more denser region will lose more molecules to region of lower density to bring the equilibrium state. Here in such case, in which has a high molecular density, okay, or which has a high concentration. High concentration or high molecular density both gives the same meaning. Okay, in such a situation, what happens, the molecules moves from high denser region to low denser region. Okay friends, so molecules move high denser region or high concentration region to low denser region or low concentration region. So why they move? To make them, to bring them in equilibrium state. Equilibrium state means latter how many molecule present here, the same number of molecule also present here, so then they become same in number. Same in number means they come under equilibrium state. This phenomena is called diffusion. When the molecules move from high density region to low density region, then such a phenomena is, or such a process is called a diffusion process. The phenomena of diffusion can be explained on the basis of kinetic theory. Okay friends, the phenomena of diffusion can be explained on the basis of kinetic theory. So here this phenomena is can be explained kinetic theory. So kinetic theory means the molecules moves in random direction. So that is explained by the kinetic theory of gases. Considering the transport of mass across a given plane. So transporting mass means transporting the number of molecules from high density region to low density region. Okay friends, next let us consider a mass of gas moving in parallel layers between planes AB and CD. Okay, so consider the mass of gas. Here mass of the gas are moving parallel layers between the plane AB and CD, where they are the planes here. So plane means like this, it is one plane. Okay, it is one plane, AB plane, and it is parallel to x-axis. And this is what CD plane, it is also parallel to x-axis. Okay, let us consider the mass of gas moving in parallel between the planes AB and CD. Okay, let Lm is an intermediate plane as shown in figure. So there is a one more plane in between these two planes. So that plane is intermediate plane, that is denoted by LM. It is a LM plane. Okay. So like this, how many planes are there? One, two, three. Three planes are there, but it is a low. It is a low concentrated plane. Okay. Suppose that concentration, see here, definition is given. Concentration definition is what? It is number of molecules per unit volume is called concentration or density. Density and concentration both are having the same definition, means they are synonyms. Okay, suppose that concentration increases in vertical direction as we go from plane AB to plane CD through intermediate plane LM. So that means it is AB plane. It is having low density, and it is which plane? It is CD plane. It has high density. That means as we move from bottom to top like this, when we move like this, then density increases, or if we move top to bottom, means from CD to AB, density decreases. Okay friends. Next, thus the concentration of gas above LM, like this, concentration of gas above LM is greater than that of the gas below LM. So this side the concentration is more, this side, and this side concentration is less. Why? Because as we move in this direction, concentration increases. Concentration increasing means number of molecules increases. In order to bring the equilibrium, so that means to make these two players equal in number of molecules. Okay, that is equilibrium. In order to bring the equilibrium, the molecules of the gas, due to thermal agitation, will move from plane CD to AB, crossing the plane LM until the concentration in every region is same. Here, because of thermal agitation, that means what? Because of temperature difference, the molecules which present CD side, means high density molecules, then those molecules move towards AB through LM plane. Okay, so towards AB through LM plane like this. Then what happens? This side density decreases, this side density increases. After certain time, what happens? On either side of the LM, what happens? Density is same. That is what we call that is equilibrium condition. Okay friends. Okay, so equilibrium means making on either side equal number of molecules. So that means this side a large number of molecules present, this side a small amount of molecules present. So that means this side low density, this side high density. So above LM high density, below LM low density of gas molecules present. Next, thus the phenomena of diffusion may be conserved as transport of mass. So like this we can explain how the mass is transporting from CD to AB. Only transportation takes place from CD to AB, not AB to CD. Next, as the molecules are moving in all possible directions due to thermal agitation, that means because of temperature, what happens? Molecules do not travel in single direction, they may travel in different direction like this. That is called random motion. Okay, it may be supposed that one third of molecules are moving in each of the three directions, move parallel parallel to Cartesian here, right? Parallel to Cartesian coordinate axis, right? Okay friends, it is supposed that one third of molecules, one third means 1 by 3 times of molecules, one third of me 1 by 3 number of molecules, one third of molecules are moving in each of the three axes. So that means in x direction one third molecule, in y direction one third molecule, in z axis direction also one third molecules moves. So that On the average, it is not average, on the average, one-sixth of molecules move parallel to any one axis in one particular direction. Okay, one third is in along one direction. Okay, so 1 by 6 is what it is parallel to the any one axis. Okay friends, so let concentration at the plane LM. So it is with plane, intermediate plane. So at that concentration is N. N means already we know number of molecules per unit volume. So number of molecules per unit volume is also called as density or concentration. Rate of change of concentration with a distance. So concentration, what happens, they changes with respect to distance. Am I right? See here. So okay, let us consider a mass of gas moving parallel to the layer between, right? Okay, over this is sorry. So where we are here, right? Okay, let us let concentration at the plane LM is N. Okay, it is in the middle only. The rate of change of concentration with the distance. So rate of change of concentration with the distance, that is called concentration gradient. That means as the distance changes, then if the uh, concentration changes with respect to distance, then we call it is concentration gradient. Okay, a rate of change of concentration with the distance, that is called concentration gradient in upward direction, perpendicular to the plane LM is what, dn by dz. Okay friends, it is a rate of change of concentration. The distance of each of the plane AB and CD from LM is lambda. Okay, see the diagram. In between AB and LM is lambda, or CD LM is also lambda. Then concentration at a plane CD. So at the plane CD, concentration is taken as positive. Why? Because n value is exactly in the middle, and as we move upside direction, concentration, what happens, concentration increases. So this side concentration is more, this side concentration is less if it is LM plane. Okay, so where if it is a AB plane, CD plane, it is intermediate LM plane, and as we move upward direction, what happens, concentration increases. So concentration increasing means what, concentration increases means as the distance changes, concentration also changes. So upside is a high concentration present, and a downside is low concentration present. Okay, and then concentration at a plane CD is this one, where lambda is what, it is a distance between intermediate plane and CD plane or AB plane. So concentration at the plane AB. So upside is a positive. Why? Because high concentration present. Downside is a negative is taken. Where here negative is taken. Why? Because downside means at plane AB low concentration present, at CD high concentration present. That is why it is written like this. Now, number of molecules from the plane CD crossing the plane LM downward per unit area per second. Here see what it is, number of molecules from plane CD. So that means they comes downside. Okay, from top to bottom side. Crossing, and they have to cross LM plane. See here, if any molecule want to travel, in this direction, means high density region to low density region, they must to cross this plane, LM plane. Okay, now number of molecules from the plane CD crossing the plane LM downward per unit area per second is what, 1 by 6 C bar n plus lambda dn by dz. So this is what number of molecules crossing per unit area per second, from where to where, from CD to LM. Okay, where C bar is average velocity of molecule molecules of gas due to thermal agitation. So because of thermal agitation, average velocity will come. So its a meaning is I explained of average means, right? Number of molecules from the plane AB crossing the plane LM upward direction, upward, per unit area per second. So it is downward from CD to AB side through LM. Now what is saying from AB to CD side. So from down to upside through LM is this one. From bottom to it is. From bottom we are taking. Bottom means our bottom side negative value present means low value, and the top side means a high value present. Next, so it is downside. It is upside. Hence, net number of molecules crossing per unit area of the present LM per second. So net, if you want to net, then subtract higher value minus lower value. So then you can get net value, right? So for this, what I am doing, see here. So net value, for net value, so from this value, this minus this is taken. Okay, this. So 1 by 6 C bar n plus lambda dn by dz minus 1 by 6 C bar n minus lambda dn by dz. Now if you multiply this side, then you can get this form. If you multiply and after multiplication you have to simplify. Okay, do it. Whether we, can you get this value or not. So please do it. Alright. So difference after difference taking, you can get this one only. And next, it is a definition of what? Diffusion definition this is. So please keep in mind a diffusion definition. Okay. So what is diffusion definitions here? The coefficient of diffusion is defined as the ratio of number of molecules crossing unit area per second to the it is, okay friends, to the concentration of gradient. Okay, to the concentration of gradient. So here to the concentration of gradient means this 2 indicates what? Division line. So before this, what is present? Molecule crossing per unit area. So molecule crossing per unit area is this one only. See here. Okay, so molecule crossing per unit area to the concentration gradient. Concentration gradient means what? That is a dn by dz. Okay, so then substitute this value here and a dn by dz. Then what happens? Dn by dz gets cancelled. Then we get 1 by 3 c bar lambda only. But we know the lambda value. What is that? 1 by root 2 pi d square n. So d is equals to 1 by 3 c bar, this one. And finally we write d as diffusion. D means diffusion c bar by 3 root 2 pi d square n. So friends, this is a diffusion. It is very small, and keep in mind while you are preparing. Okay friends, thank you. Don't forget watching this video till the end. Okay, thank you.